Okay, so the next thing that we have here is basically another question which could be pretty useful in many situations. For example, let's say that you have basically this situation over here. Let's say that you have A is equal to 1, 2, and B is equal to, for example, another set 1, 2, 3, 4, 1, 2, 3, 4, and C is equal to 5 comma 6, and D is equal to 5, 6, 7, 8. And D is equal to 5, 6, 7, 8. So you can see that basically A is a subset of B. A is a subset of B, and C is a subset of D basically. C is a subset of D. Now there are two things that we want to verify. So this is based on the question. We want to verify that the Cartesian product of A and the Cartesian product of A and B intersection C is equal to the Cartesian product of A and B, the Cartesian product of A and B intersection with the Cartesian product of A and C. So and you can see that basically the intersection of B and C is actually a null set really. The intersection of B and C is a null set. So what that means is that the Cartesian product of basically the intersection of B and C is the null set. So that is the Cartesian product of the one and 2, 1, 2, 3, 4, 5, 6, and 5, 6, 7, 8. Okay, so now I don't understand why they have actually asked this question, because it kind of makes no sense. But let's see. You see that the set B is basically 1, 2, 3, 4. C is 5 and 6. Okay. So now if I take basically if I take B intersection C as the null set, that the Cartesian product of basically the Cartesian product of A and B would be basically the Cartesian product of A and B would be basically 1, 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 4, and then you have 2, 1, 2, 1, you have 2, 2, 2, 3, and 2, 4. Now this is the Cartesian product of A and B. The Cartesian product of A and C is equal to 1, 5, 1, 6, 1, 5, 1, 6, 2, 5, 2, 6, and you see that the basically 1, 1 is not here, 1, 2 is not here, 1, 3 is not here, 1, 4 is not here. So basically so you can see that the intersection of these two sets is basically the null set. And of course the Cartesian product of the null set with any set is the null set, so a null set is equal to the null set. So this is verified. Now I don't really know if that applies to any 3 sets generally, but that way you can verify this kind of thing over here. Or as another question, let's say that you have A is equal to the set 1, 2, and B is equal to the set 3, 4, and the Cartesian product of A and B, the Cartesian product of A and B is equal to basically 1, 3, 1, 4, 2, 3, 2, 4. So you have basically 4 elements here. Now you see that the n of A, the number of the elements in set A, is equal to 2, and n of B, the number of elements in set B is equal to 2. Now the n of A times B is equal to n of A times n of B. And of course you know that this is ordinary multiplication of two real numbers. This is the Cartesian product of two sets, so you need to be careful about that. Now n of A times B is basically n of A, which is equal to 2 times 2, which is equal to 4, and that agrees with the number of elements here. So that is that. Now we have another question over here, question number 9, which is, let A and B be two sets such that you have two sets A and B in such a way that basically n of A is equal to 3, n of A is equal to 3, and n of B is equal to 2. Now if these if basically if you have A times B, if these elements are in A times B, meaning x, 1, for example y, 2, and z, 1, and you would have basically more elements over here. Find A and B where x, y, and z are distinct elements. We want to find A and B where x, y, and z are distinct elements. Okay, so basically n of a is equal to 3 and n of b is equal to 2. That means that n of a times b has to have 6 elements. There has to be 6 elements over here. Now, so since well, okay, I was actually under the impression that I was supposed to actually find what x, y, and z are. Now, since you know that x comma 1, y comma 2, and z comma 1 are the elements of this set A times B, or the Cartesian product of A and B, then basically you know that these first elements, of course, have to come from the set A. That means that there are the 3 elements of A would be x, y, and z. And of course, since I know that n of A is equal to 3, but then I can say that basically the only 3 elements that A has is basically x, y, and z. And then B is going to be equal to basically 1 and 2, these 2 elements, and this has been repeated. So 1 comma 2, and then we know that n of B is equal to 2, so that's basically the 2 sets A and B. I thought that I was supposed to find the values of x, y, and z, which is actually not possible in this case. So now there is another question over here, which is a little bit, and let's actually solve this question of this problem as well. It says that the Cartesian product A times A has 9 elements. Among which are found basically A times A is basically this set. It has some elements. One of them is negative 1 comma 0 and also 0 comma 1, and you have basically 7 more elements over here. 7 more elements. Find the set A. You want to find A and the remaining elements of A times A, and the remaining elements of A times A. So what that means is that now I need to take a look at the solution here, because this thing over here is the kind of thing that I did not understand. So what I'm going to do is I'm going to read the solution here. So we know that n of A is equal to n of B is equal to Q. Okay, so the solution that they have used here is basically you know that if n of A is equal to P and n of B is equal to Q, we said that then n of A times B is equal to P times Q. We already talked about this. So what that means is that based on this we can say that n of A times A has to be equal to n of A times n of A times n of A. And again here, this is not normal multiplication, but this is normal multiplication. Now we know that n of A times A is equal to 9. So then what that so that means that 9 is equal to n of A times n of A. And of course basically then since n of A is equal to n of A, so then basically if you factorize this number, you will get 9 can be written as either 1 times 9 or 3 times 3. So that means that n of A is equal to 3. Now, so now we know that the ordered pairs -1, 0 and 0, 1 are two of the 9 elements of the set A times A, and also we know that basically A times A is equal to this set of ordered pairs A, A, such that A belongs to the set A, which means that -1, 0 and +1 are the elements of A, which means that -1, 0 and 1, therefore A is equal to -1, 0 and +1. And since A has only 3 elements, that is the only 3 elements that you could find in A. Now my problem was basically in this area. When you want to write the elements of A times A, based on now that I have basically found the set A over here, if I want to write the elements of A times A, is basically so you can write basically -1 times -1, 0, -1, -1, 1, let's see how we can do that. So I guess we get 9 elements over here, so we get -1, 0, -1, 1, and then we get 0, -1, 0, -1, and 0, 1, and then we get 1, -1, 1, -1, and 1, 0. And there you have 1, 2, 3, 4, 5, 6 elements here. Zero, 1, 0, -1, 1, 0, 1, -1, and then -1, 0, -1, you see, suppose that to do this more easily, what you can do is that suppose that, for example, if you had two basically two sets, for example A and B, suppose that the elements of A are A, A, B, and C, and the elements of B are are D, E, and F, then A times B is going to be equal to A comma D So the elements of A times B would be basically then A comma D, A comma E, A comma F, and then with B comma D, B comma E, B comma F, and then C comma D, C comma E, and C comma F. So then you can do the same thing over here, meaning that you can write A as, well, as it is. A is equal to basically this set -1, 0, +1, and then the same set over here again. A is equal to -1, 0, and +1, and A comma A, and I'm sorry, A times A is going to then be equal to -1, -1, -1, 0, -1, 0, -1, 1, and then you have 0, -1, then you have 0, 0, then you have 0, 1, 0, 1, 1, -1, and 1, 0, and 1, 1. And that is basically all the elements of A times A. Okay, so that's basically that. Now in the next video we will talk about relations, so I'll see you in the next video, and thank you.